Welcome to the Walton Pi. Today we're going to be talking about derivatives of polynomials. So a polynomial is a very common function that we're going to come across, so it would be helpful if there is an easy way to always find the derivative of a polynomial without having to go through and do those limit definitions every single time. So let's look to see if we can just do the limit definition once on a generic polynomial and see if that can translate into a general rule that will apply for all polynomials. So if we let f of x be equal to x to the n, and then we are going to go through the limit definition of the derivative, we can figure out what is going to be f prime of x. So we start off with the definition. F prime of x is the limit as h goes to 0 of f of x plus h minus f of x all over h, which is just going to be the limit of x plus h all to the n minus x to the n over h. Now, x plus h to the n, there's a theorem called the binomial theorem that then allows us to be able to expand that out into a series. And then that series is a little bit complicated, but we're able to pull a bunch of stuff out and rewrite it a little bit, which then simplifies to the limit as h goes to 0 of n times x to the n minus 1 plus h times the sum from k equals 2 to n of n choose k, x to the n minus k, h to the k minus 2. Now as h goes to 0, that entire sum is going to end up being multiplied just by 0, which means all we are left with is the n times x to the n minus 1. If you're curious about that, feel free to check out my video on the binomial theorem. But if not, we can just accept that the derivative of a times x to the n is just going to be that constant a times n times x to the n minus 1. And this is what's called the power rule. So if we are given this sort of polynomial, we can use that rule every single time. We have a whole bunch of additions combining a bunch of different x to the different n values. So what we can do is we can say, well, the 7x to the 6, that is going to become 7 times 6 times x to the 6 minus 1. The 2x squared, that becomes 2 times 2 from the exponent times x to the 2 minus 1. 4, the derivative of a constant is 0, or you could think of that as x to the 0, so it's 4x to the 0, so that becomes 4 times 0 times x to the 0 minus 1, which is just always 0. And then the last one is 3x to the minus 2. That's going to be 3 times negative 2 from the exponent times x to the negative 2 minus 1, which simplifies as 42x to the 5th minus 4x plus 6x to the minus 3. So that's going to be the derivative without having to find the limit. And so that's going to work for any power of x, as long as x is raised to a constant power. I hope this video was helpful. Please check out some of my other videos, and please like and subscribe if you haven't already so that I can continue to make these sorts of videos. Thanks so much, and have a great rest of your day.